Hi, this is Margo. This is Sunday afternoon, February 28th, 2021, and I'd like to welcome everyone to the show today. This will be my weekly update for methane and sea ice and climate roundup for my YouTube community and others who are following me. And I hope everyone is safe and well, and I had kind of a rough week. My voice is still kind of rough, but I'm here and going to do the show. So we're going to start out with, I'm going to lead off with this article. Everybody's heard about this. It's the Brunt Ice Shelf calving a new iceberg, A74, and it's this article came out a couple of days ago from the BBC, and there's a video of, I'll leave the link below. You can watch the video of them going along the crack there. Well, we can watch it if you want. No, it's got an ad. You know, I'll just leave the link below and you can watch it if you want. It says, big iceberg approaching the size of Greater London has broken away from the Antarctic close to Britain's Halley Research Station. Surface instruments on the Brunt Ice Shelf confirmed the split early on Friday. No one is currently in the base, so there's no risk to human life. The berg has been measured to cover 1,270 square kilometers, nearly 490 square miles. And Halley is positioned just over 20 kilometers from the line of rupture. The BAS has an array of GPS devices on the Brunt, and these relay information about ice movements back to the agency's headquarters in Cambridge. So here's a picture of the cracks. This is from Copernicus. This is just a 2-image back and forth from, this is like from NASA Worldview, but I can show you that too. Professor Adrian Luckman has been tracking satellite images of the Brunt in recent weeks and predicted the calving. Although the breaking off of larger parts of Antarctic ice shelves is an entirely normal part of how they work, large calving events such as the one detected at the Brunt Ice Shelf on Friday remain quite rare and exciting. With 3 long rifts actively developing on the Brunt Ice Shelf system over the last 5 years, we have all been anticipating that something spectacular was going to happen. Time will tell whether this calving will trigger more pieces to break off in the coming days and weeks. At Swansea University, we study the development of ice shelf rifts because, while some lead to large calving events, others do not. The reasons for this may explain why large ice shelves exist at all. So here's an outline of the part that's coming off. And there's this whole thing is the Brunt Ice Shelf, but you can recognize it with this kind of a curve that comes in. It's by the Weddell Sea. Saying, where is this? It's a floating protrusion of glaciers that have flowed off the land into the Weddell Sea. On a map, the Weddell Sea is the sector of Antarctica directly to the south of the Atlantic Ocean. The Brunt is on the eastern side of the sea. Like all ice shelves, it will periodically calve icebergs. The last major chunk to have come off in this area was in the early 1970s. Now here's a picture of the Haley research station that they had to evacuate. Was the breakaway anticipated? Absolutely. Scientists continuously monitor any major cracks in the Brunt and have been following the propagation of quite a few in recent years. Indeed, it was an acceleration in the movement of these fissures that actually prompted BAS to relocate Haley upstream in the flow of ice in 2016 to 2017. All the major cracks coverage on a location known as the McDonald Ice Rumples. This is a pinning point, a section of shallow seafloor that the Brunt must grind past. One particular crack, called North Rift, spread out from the rumples to draw the outline of the iceberg that is now calved. Here's another image. Just how big is it? They estimate it to be around 1,270 square kilometers. Greater London is about 1,500 square kilometers. The Welsh county of Monmouthshire is roughly 1,300 square kilometers. That's big by any measure, although it's not as large as the monster A68 berg, which calved in July 2017 from the Larsen Sea Ice Shelf on the western side of the Weddell Sea. And I've been following that A68 and showing that to you guys regularly. But even at a quarter of the size of A68, the Brunt block will need to be tracked because of the future risk it could pose to shipping. The U.S. National Ice Center will give the new berg a designation in due course because it is in the same Antarctic quadrant as A68's origin. The Brunt berg will also carry the letter A in its name, and it's likely to be called A74. And this is ice velocity on the Brunt Ice Shelf, and we can see that area is up in the highest right there at 4.0 there from point 1. BAS Director Dame Jane Francis commented, "Our teams at BAS have been prepared for the calving of an iceberg from the Brunt Ice Shelf for years. We monitor the ice shelf daily using an automated network of high-precision GPS instruments that surround the station. These measure how the ice shelf is deforming and moving. We also use satellite images from the European Space Agency, NASA, and the German satellite TerraStar X. All the data are sent back to Cambridge for analysis, so we know what's happening even in the Antarctic winter when there are no staff on the station and it's pitch black." And they ask, is this climate change in action? And the answer they say is no. The calving of bergs at the forward edge of an ice shelf is a very natural behavior. A shelf will maintain an equilibrium, and the ejection of bergs is one way it balances the accumulation of mass from snowfall and the input of more ice from the feeding glaciers on land. Unlike on the Antarctic Peninsula on the other side of the Weddell Sea, scientists have not detected climate changes in the Brunt region that would significantly alter the natural process described above. What is more, estimates suggest the Brunt was at its biggest extent in at least 100 years before the calving, and that this event was overdue. So here's a picture. Here's South America. Here's the Western Peninsula. Here's the Weddell Sea, and the Brunt's right down here. And that's the article. So I will leave a link below. There are more articles out there, and some say it's 20 times bigger than New York City. So, I don't know. You can check it out. But here on NASA Worldview, here we are today, looking at the Antarctic, and we'll just zoom in. This is the Weddell Sea, and the Brunt Ice Shelf is right here to the east of the Weddell Sea. And when we zoom in, here we are, and here's this curved part, kind of a semicircle there, and the part that's coming off is right here, and there's a little bit of a cloud over it, but you can definitely see the breaks through the cloud, and it looks like it's coming off. This crack is much bigger than a couple of days ago, and we can see open water here where it's pulled out. So, and there's a cloud down here. So if we go back to the 26th, this was the first day that it was shown. This is the picture that's in the article, and you can see the biggest crack right along here, and then all the way up, and it kind of does a little stair step here and comes out. And the last good picture was the 19th, because it's been really cloudy here. So if we go back to the 19th, we can see there are no cracks along there. There is this crack, and this one. Now this is the big chasm one down here, and then this is the Halloween crack, and this is the new crack that they discovered and showed just this year. And so now if we go to the 26th, see, it's this part of this new crack. The Halloween crack is still over here, so it's part of this. This is the new crack that they showed us a while back, and so you can see the outline here. And then that was the 26th. I'll just click through so far. Here's the 27th, and so there's a cloud over it, but you can see the crack opening up here, and then here's a cloud, and this looks like two satellite images that they coming together, and it looks, I don't know, it's kind of hard to tell if they just didn't do a very good cut and paste or what's going on here. And then here it is today, but today it's the same. There's a hole opening up. See, so this bringing the two images together, that's going to end up somewhere else today. So this is all one image, it looks like, and we've got a cloud, pretty thick cloud over here on the right, and light cloud cover over here covering most of it. We can see through the cloud this where it's pulling out. So see, that's a large area already where it's pulling out. So it looks to me like it's coming out, but it's kind of at the end of their summer, and the sun has started to go down. I don't know if it's going to pull out completely before the sun goes down or what's going to happen, but this is A74, and I will keep all of you posted on this, and in my reports to my Subscribe-Star members. I do numerous reports during the week and do updates on the sea ice and methane and earthquakes and stuff, and we'll definitely keep everybody posted. And then weekly here on YouTube we'll keep an eye on this A74 now. So there's that. I knew exactly where that was when I saw the article, and I was able to find it easily. I wonder how that's going to add to sea level rise. So no one's talking about that, but that's a big chunk. Not as big as A68 was, but it's definitely a big chunk. Now let's move on and let's go on with our regular report. I have the NOAA methane data for yesterday, the 27th, for the 477/469 millibar reading. This is the Met-1 satellite. In the morning, the mean or average was 1,896 parts per billion. The high reading was 2349. In the afternoon, the mean was 1896 again. The high reading was 2387. On the Met-2 satellite in the morning, the mean was 1875. The high reading was 2378. And in the afternoon, the mean was 1874, and the high reading was 2337. Now here's the spreadsheet that I've been working off of and our chart. So here's the data for the 27th, and it averages out to 1885.25 parts per billion, showing an increase over the week before of 4 parts per billion. So here on our chart you can see this line, a steep increase of 4 parts per billion. Now remember, in my report last weekend we had problems with NOAA in the data was incomplete for Saturday, so I took the Friday reading for the week. So this is actually a week and a day later, but that's what we counted for a weekly. So it looks to me like we're on the increase now. So we did hit our low for this winter season on January the 12th of 1873.5 parts per billion. That was right over here on the graph. And we've kind of been stair-stepping since then, and now it looks like we're on the rise. Now I started tracking this methane in 2019. Dave Alcock and I were doing it together for a while, and then I decided to just track this level on my own, and he tracks a whole bunch of different levels and averages them out together. So I'd like to thank Dave for bringing this to my attention, that this is something that does need to be tracked, and he and I are the only ones that I know of that are tracking this as kind of citizen researchers and reporting on it. So we're not paid by any organization or anything. We're just doing it, and we both see increases, exponential increases in methane from year to year. And it's one thing to have someone, to read an article and say, oh, methane went up this much. But it's another thing to track it on a daily basis, which is what I've been doing now for the last year. So since February 29th of last year, it's gone up 8.75 parts per billion. Since March the 1st of 2019, which is the first data I have on this, it's gone up 28 parts per billion. And since and this time last year of February 27th, a year ago today, now we're 13 parts per billion higher. And in the first year, we went up 19.25 parts per billion. So what's concerning about this is that at the low periods, we're not going down as low as the low periods before. So when we start back up, we're higher, much higher than where we started to go back up. And so it's on a perpetual increase, it looks like. And it's kind of baked in the cake. Now, here's what happened this week, and I did document all of the data, what I had. Now, so here was the 20th, where they started out having no data for the MET-OP2 satellite. So there were 2 days of that. But over here, I decided to put the data in for the MET-OP1, and so the MET-OP1 went up 3 days in a row. It went up, just tracking the MET-OP1 by itself, it went up 2 parts per billion 3 days in a row. Then on the 22nd, there were 3 readings that were okay, and then the MET-OP2, there were 2 readings that were okay. MET-OP1 was okay, but on the MET-OP2 satellite, there was no data for the AM reading, and on the PM reading, about half of it was missing. So this is what I came up with on the average for the three readings, and so we can see that's out of whack. So anyway, then on the 23rd they got stabilized with their readings, and so it had gone up 2 parts per billion by then, like what I'd seen over here. So even just tracking the MET-OP1 data can give us an indicator of what's going on. So, and then the 24th, it went up 0.75. On the 25th, it went up 1.25. On the 26th, it went up 0.5. And then on the 27th, it went down 0.5. So the highest we had this week was at on the 26th at 1885.75, where we had gone up 4.5 parts per billion this week, and then it went back down. And we should see a little bit of stair-stepping. To just see it going up, up, up without any pullback is not a good sign. And then over here, I have yearly change to the day, because I started in February of last year tracking the daily data if it was available, So I can go back to the actual day and just pull the data and say, well, this time last year we were at such and such, and now we're this much higher. So that's kind of a handy feature to have. That's another advantage to having to tracking it daily. So right now, today, we're 13 parts per billion higher than we were a year ago. So there's my NOAA report. Now we'll look at the CAMS data. I have Saturday, February 27th up. Let's get on the Arctic view. We'll start with that. And surface level. There's our color ledger. So the data is for Saturday, and the forecast runs Sunday through Wednesday. There we go. So while this is loading, I just want to say we've had some releases coming up here in this ESAS area this week, and it started around Thursday, and some of it, now we'd seen waves move out across, like from CAMS, but this is definite just coming up from this area. So that's coming up through the sea ice. This is in the sunlight now, and we can see in the forecast period, see it's kind of swirling around and moving into the red zone too. So it's quite a large area. So I don't know if the sediments are starting to break loose the methane there. I mean, it could be. This is the area that Natalia Shukova has been, that she talked about in her big research paper, and her partner and husband Igor Samilitov, they've been focusing on this area, but also other areas of the Arctic. And see, it's still spewing up here by CAMS and in the North Kara Sea, and no one's talking about that, and it's been constantly spewing up right there for the last year, and no one seems to be up in arms about that, but this is the big news at the ESAS. So I would think someone would at least say something about this at the CAMS. Maybe they'd send a drone out there or something with just to get a sample to see what was going on. I mean, if it were my territory, I'd want to know. We've still got high releases here on the north coast of Alaska. We can see primarily we've got greens, just a tiny bit of blue sifting through, but it's covered with green, and then our background color is getting higher, moving up into the yellow green and the yellow and orangey color now. So that's a sign that we have higher methane readings overall. Now we'll go to the North Pole view. Now see these waves of green? That's another sign of high methane. See this moving out from Europe and then here's some, look at, this is the UK just gets covered up with high, and Ireland over here just gets covered up with high levels of methane. See the wave moving out. And green down over the Arabian Sea and down from India, and here's the Bengal Bay. Now this, see, we're still seeing some high readings, but not like they were. So it's kind of shifting. Instead of seeing the black stuff coming up out of the Bengal Bay, it's just kind of redistributing, it looks like. We still have very high readings throughout India. This Persian Gulf is still kind of filling up here. Here's China, it's filling back up. And in North America, it's pretty much all green. Now, this is different because we used to see quite a bit of blue from about Texas over west, but now it's like a constant green hue. So that's an indication of higher methane overall as well. Just to my eye, this is just what I'm noticing just from day to day. And see this green, the green waves moving out over the Atlantic, over the Pacific. And then global view. Now, down here in the southern hemisphere, we're seeing more of the dark blue come up. That reading is 1800 parts per billion. That's so that's higher than this purplish color, which was 1780. And we'll be seeing more and more of the blue and the light blue coming in further south as methane readings go back up as well. They will redistribute worldwide. There's that. Now we'll look at 500 HPA. Now this is pretty equivalent to the level that we see on the NOAA data. And the highest reading is here over the West Pacific. Now this came off of China and is drifting across. And we see a lot of reds covering this northern part. And we're seeing the greens coming further south, so the yellows popping up further south too. And now we'll look at total column. Here we are. Here's China, India. You can see a redistribution here. And then the red-orange, a lot of red-orange from southern India across the Pacific. And we're seeing higher readings total column-wise over South America. And It's even going into that dark red here. It's been light red, but now it's going into the dark reds. And this is over Bolivia, but it could be drifting down from Brazil, from, not sure whether it's the deforestation that they're doing of the Amazon, or what's going on with that. Let's move on with our report. Now we'll look at sea ice. Here we are today. This is sea ice and snow cover from Climate Reanalyzer for today. Here's the Arctic. We can see a little bit of regrowth here in the Barents Sea. They've had problems up here just west of Svalbard because of the warm air over here, but also the warm water coming up from the Atlantic. Also around Greenland, this is quite warm. We can see a little bit of refreeze here in the Great Lakes region. So let's go through, and also we'll go through our slideshow for this week. So here we are last Sunday, the 21st, it's the 22nd, 23rd, 24th, 25th. So we're actually seeing a retreat up here of the Barents Sea. Here's the 26th, 27th, and 28th. So that looks like a little bit trying to come back right there, but this was a retreat because of the warm air. So I stand corrected there. Now let's look at this is from the U.S. Navy website. This is sea ice thickness for today on the Arctic view. As we zoom in, we can see what's going on here. There is a hole here next to the nearest strait. I don't know if it's from an icebreaker going through. When I looked at it close up, it was very defined edges. So I just don't know. I don't have that data to know when they ran the icebreakers, or if they are running icebreakers through there or not. There's also a hole that's opened up here on this northeast edge of Greenland. Here's Svalbard, and we can see it's empty on the west of Svalbard. It's also melting around the Franz Josef Land Islands here. It's also melting around Komsolomitz and up here, up to along this Russian coastline. And it's melted just north of Novaya Zemlya. You'll see that on NASA Worldview as well. Now we've seen mainly thickening as see this is moving into the aqua now, into quadrant 1. Now quadrant 2 is mainly purple and blue and not much ice at all because of the way everything's situated. So most of the ice is in quadrants 1, 3, and 4. And there's just a little, see, this is a small quadrant, and the North Pole is right here. But this is just north of Greenland, and that's thickened up. Now this area is what was left of the thickest sea ice that had been over here from Ellesmere Island down here. along this Canadian archipelago, and this winter it's been sliding down. We've been watching it, and now it's compressing and sliding down into this Beaufort Sea area and not moving much. It's just it's kind of sitting and anchoring in, and it's thickening, going into some greens. We've got a few reds over here. I'll show you those in a minute. And then in quadrant 1, this is the Chukchi Sea, and over along the Siberia coastline we're seeing some thickening, and it doesn't seem to matter for the methane because we're seeing the methane on CAMS. It's in this area where we're seeing it popping up. So the ESAS is right along here. The East Siberian Arctic Shelf actually goes all the way over to here. All along here. And this is the Laptev Sea, and here's the Kara Sea. Now here's the 30-day animation. Now this ends on March the 6th, so that's 6 days out from now. And then the data goes back 3 weeks. So let's zoom in and see what's going on. See what they anticipate for the next week. So more thickening, basically. And the sun is up. I mean, not completely, but this area by Greenland is now in the sunlight. This little foot of Svalbard is now in the sunlight. Novaya Zemlya is all in the sunlight. All the Russia coastline, all the coastlines are in the sunlight, except for right up here around Greenland. So it's coming back. It's not full on bright sun because it's low on the horizon, but no more dark winter days for a lot of this Arctic region. So we're seeing more melting here around Franz Josef Land. See the white come in. And tiny bit of regrowth here in the Baffin Bay. It's trying, but it's coming down as it's coming down from these little inlets. It's probably making the water colder, and then it's able to refreeze, make the extent come back a little bit more. That's my theory. Now we have a thinning going on this west side of the Hudson Bay. See? So, for whatever reason. Now here's the Beaufort Sea ice thickness. So Alaska's down here. This is the Canadian archipelago here. And the thickest part is right along here, just along this coastline. It's going up to 5 meters thick there, just this little ribbon, and then a little bit of red here, and then along the Alaska coastline we've got some reds, and then we can, this is about the same with the shape and the where we see the leads. It's about the same. Now here's the 30-day animation, and see, it's not much movement now. It's mainly thickening and kind of just compressing. Now it looks like, let me stop it, at the end of the, so a week from now, it looks like this is, see, it's not as thick here along this Alaska coastline, so it looks like it's coming away there. So if we go back, see, it's pulling away. Probably the ice drift is pulling that away there. Here we are today. So we'll just click through. There's the first, second, third, fourth, fifth. See, it's pulling away there on the 5th. That was the first day you can really see it. 6th and 7th. Here's the ice drift for this Beaufort Sea. This is the 30-day animation, and the blues are calm, and where you see all the colors, that's where it speeds up, and you can see the arrows. So let's go back. So here we are today. It's pretty calm. See, this dark blue is no movement, and then as it goes up in the colors, it starts to move faster. We can see these arrows. The direction is downward towards Alaska. So we'll just click through and see what kind of movement we're going to have this week. Here's the first, not much movement there. Here's the second. See, mainly blues. The third. I don't know if the thickness of the ice is causing the movement to be less. Now it's here, it's speeding up here in this Bering Strait. See that on the 3rd. So that could be what's going to pull that ice away. Let's see. There's the 4th. See, it's calm on the 4th. Ooh, look at this. Look at all this movement on the 5th. Now that's what's pulling that ice away from the coastline. 2 more. Let's see. There's the 6th. A lot of movement here. And then the 7th. And then it's calm there. So we'll just see what transpires this week. Here's the Baffin Bay. This is the new model that the Navy has put up. They put this up on February the 12th. So this is about halfway up in the Baffin Bay, and they don't go all the way up to the top of Greenland. It's just about halfway up. So this is open water here. We can see a little bit of fringe trying to freeze there, and in these inlets the sea ice exits. It comes out and down. Now here's the animation starting on the 12th. So you can see the movement of the sea ice coming out through those inlets, and then it's causing the extent to to grow here in this Baffin Bay. It's hard though because this sea surface is so warm. This is the sea surface temperature there today, and this dark reddish, I call it black, that's 4C is the temperature. So we even have a little area here at 4C, and then it goes down. And in order for this water to really freeze, it needs to be about -2C. Now we'll look at the Antarctic. Here's the sea ice thickness for today. And we can see this has really melted down. There's a little bit of refreeze starting here in the Ross Sea and over here on the west side. And down here on the southern side, you'll see not very much, it's just a little fringe. Now here's the 30-day animation. And then in the week coming up, you'll see the little fringe starting out here in this Ross Sea. So that's showing me a little bit of refreeze happening now. So there's that. That's all of those. Now we'll move on to where do I want to go next? Let's go to Climate Reanalyzer. This will help us understand what we see when we look at NASA Worldview. This is maximum temperatures for today. So now last week we saw a lot of warm air entering here, coming up past the North Pole, but now we're seeing cold air coming back. There are still some warm pockets, but it's not above freezing. Here's 2-meter temperature anomaly for today. See, look at the red here just left of Svalbard, and up here in the Barents Sea. Also here in the Arctic Basin in Greenland is kind of reddish brown. Then we've got the cold air coming down because of the broken jet stream. I'm calling it jet clumps now. I don't even call it a jet stream. It doesn't even look like it's streaming. And blue coming down over half the U.S. and then brown over the rest of the U.S. And we've got a mirror situation set up on the other side of the Arctic with the purple and blue coming down over Russia, and then the brown right next to it. See, and where you have the warm air meeting up with the cold air, that's where you have the chaotic weather. And see the browns over Norway and the Scandinavian area and all the way down. And this is what we got right now. So the Arctic is up 0.6C higher than normal. Well, it's better than 2C or 1.5 or whatever. The Northern Hemisphere is up 0.3C. Worldwide, we're up 0.1C higher than normal. The tropics are up 0.2C, Southern Hemisphere is down 0.1 C, and Antarctica is at a minus 0.5 C, lower than normal. Here's our precipitation and clouds for today. Now, it has been raining here at Iceland. There have been lots and lots of earthquakes here, and they're worried that volcanoes are going to start going off now. Now, we do have a tectonic plate line that runs right through Iceland, so it is predicted that Iceland will break apart at some time in the future because of the plate line. And with the melting sea ice, of course, it changes the weight on the tectonic plates, and I mean the shift of the mass and everything, and with the not the melting sea ice, I meant to say with Greenland and the different ones, we had the weight changes on the tectonic plates. So what we're seeing is isostatic rebound. That's what I was trying to say. And now it's raining up here by Norway, and then the blue is snow. So there's that. It's raining right down here in the South Atlantic. Now, it had been raining by this western peninsula, but now it's moved over a little bit. But that's not boding well for any sea ice that's down there. Here are the jet clumps for today. See, there's no stream. It's just broken. See? Makes no sense, and it's not holding in the Arctic air. We saw our sea ice and snow cover here. Here's sea surface temperature anomaly for Friday. It's the last day. We still got browns up here in the Barents Sea, and browns around Svalbard, and see browns and reds around Greenland. Now we do have a colder area right here. See, it's in the purple, a little bit of colder area, but this area just off the coast of northern United States and Canada, it's always red. I don't know why. If someone can explain that to me, I would appreciate it. It's reds and pinks, so that's up to 6C higher than normal. Ever since I've been looking at this area has been that. I don't know why. We've also got some higher readings down here in the Gulf of Mexico still. We have a colder area here in the Pacific around the equator, and this had been kind of a red blob in the South Pacific. It's only a brown blob today. So the North Atlantic is up 0.5 C, higher than normal. North Pacific is up 0.2 C. Northern Hemisphere is up 0.3 C. Southern Hemisphere is up 0.3 C. Equatorial Pacific is down 0.4 C. Worldwide, we're up 0.3 C, higher than normal. There's that. Next, we'll look at, this is the National Snow and Ice Data Center. Now, they put this announcement up. They said that sea ice index processing is currently having problems. Daily values after February 19th are erroneous. NSIDC is investigating the issue and will correct it as soon as possible. So we don't have any data here for our sea ice concentration. Now we do have, no data on the daily. All we have is monthly. That was as of January. So I like to look at the daily data. So no daily data. So now here's the chart for sea ice extent, and this is as of February 25th, it looks like. Now let's do a view image and we'll go bigger. I'm assuming this is just because they're not processing their data that we're seeing that line drop off like that. Now last week we were below the 2012 line, and this week we're it looks like they changed the baseline, that the baseline has been changed, because I remember specifically last week we were below the 2012 dotted line. Now my show last week was on the 21st. So they're saying as of the 19th their daily data is wrong, or they don't have it. So it's anybody's guess what they're going to come up with there. So they do have data on the Antarctic, and here's our concentration here for the Antarctic. This correlates with what we saw on the Navy website. And here's our chart here, and we'll view the image. Antarctic Sea Ice Extent, and when we blow it up, there's a break in the data for a couple of days here, it looks like. But the blue line is this season. This dark gray is last year. And we're still below the gray. We're still at the bottom. But it looks like it's not going down any further. It's about the same. So that's why we're able to see a tiny bit of refreeze come back. But it looks like we should be about at the bottom, and it should be starting to refreeze any time. So there's that. Now we'll since we're already down here in the Antarctic, we'll just take a tour and see what we can see here. This is the South Georgia Island here. Here's a piece of A68. It's been breaking up this week. Here's some more pieces. Here's another piece under this cloud. We can't really see this. Here, this cloud is thicker. I'm thinking this is probably the largest piece left here. I think that's some more pieces, but it's been breaking up this week. Here's this here's the Western Peninsula, and this, we've got a cloud here. This is the Larsen Sea Ice Shelf. Right here, this is the area where the A68 had broken off. So that was like 2.5 years ago that happened. Now down here, kind of getting lost. Oh, here we are. This is the Pine Island Glacier. They've kept this cloud covered, and this has not melted. This area down here, it had calved off last year, and all of this was ice free last year. But then when it froze back, it's just stayed frozen this year for whatever reason. So we can see that it's cloud covered today. We can't really see what's going on here. Yesterday, here's more clouds. See, every day it's clouds. Now, here on the 25th, here's some cloud. That's about the best view. Here's looks like a hole in the ice right there. Here's another view on the 24th. So, let's see, all of this is where it had refrozen, and it's still frozen, which I'm very surprised that it's still frozen. We can see the cracks here, but I think they're going to keep it frozen this year. The Thwaites Glacier is over here again. A lot of cloud cover, hard to see what's going on. This was on the 24th again. Here we are. And that's the texture of the ice. This is where it had broken off here. It had refrozen. And this was part of the tongue this broke off, I don't know, a few years ago. It's still in the process of breaking up and spreading out. So there's that. That's still... I'm surprised this didn't do more melting this year. Here we are today. Now we can see that it's melted up to the coastline, right up to the ice level, the little ice lip. A lot of these areas. Here's the Ross Sea. So here's the refreeze starting. Here's that little fringe of ice. This is ice starting on the refreeze. See, here's the ice shelf. Here's Ross Island. Lots of clouds here today. This this looks like a little bit of refreeze starting back too. Here on the south end. Here's the Totten Glacier. Let's see. Here's some, that looks like some refreeze starting. Here's the east side. Here's the Amory ice sheet. Now, this big piece, big area of ice pieces, it had broken off. It had been anchored in right there, but it broke off. I think it's moving out. It's hard to tell because it's so cloudy. This was last Sunday, and we can see where it was moving out. See where it broke off. But I think it's going to refreeze before it has time to move out. Let's see. Let's just click through. See, this is just cloud covered. Here we are today. Hard to tell. Now here we can see the flow. I have not seen ice ponds or, the pooling. I've not seen that. I've been looking, wanting to see it. And here's the north side. This is, it looks like this could be starting into a little refreeze as well. And then we end up over here at the Brunt, which is where we started out, the Brunt ice sheet. And the piece A74. Here's the Weddell Sea. It's cloud covered today. And that's what we've got up there. Now let's hop up to the to the Arctic. Here we are. Let's refresh, see if there's anything else. Okay, so we're missing. We don't have all the data in for Alaska and the Bering Strait yet, but that's okay. So this is where it's still dark, so you can see the sun's up for most of the area. Most of the land, the sun's up. Here's sea ice concentration layer. Here, I'm gonna turn on the blue marble view. Maybe that'll make it easier to see. And see, it's melting here by Greenland and here by Svalbard. Here, this is where it's melting at Franz Josef Land. Here, this is Novaya Zemlya, so north of there. Here's Severnaya Zemlya, and then there's a hole that's opened up between this island here and over to the coast. And here's the Greenland by the nearest strait. There's a hole here. We'll look at that too. So I'll turn that layer off. Now, where do we want to go? Let's see. See what we can see. Just eyeballing it. A lot of clouds. There is a hole right here. Let's see if we can see on the nighttime view. Yeah, here is, you can see the hole here. Let's turn on the sea ice. Then, over here by Greenland, here's the ice edge. Let's see. Let's go back. Yesterday it was much better. It was just a much better view yesterday. Here, see around, see all the open water there. Now here on the west side of Greenland we can see better. And then it's nearly straight. It almost looks to me like this was cleared out. I don't know if that's a huge area for an icebreaker to clear out or what. If anybody has any ideas, here's another area that's open. You know, if anybody has any ideas, you can put them in the comments. And here's the east side. Here's Svalbard. Let's turn on the ice again. So this is open water here. Now here's Franz Josef Land. So we can see that's opening up there. See, you can, here's the land, the white, and then the dark area. That's open water there. Let's see. Here's open water there. So there are areas where there's just a lot of open water. Here's some more. See? I think that's what shocked me so much when they showed the pictures from when that ship went to the North Pole. But now I'm understanding that there's just, you know, it's not solid. Okay, here we are next to Combe-Solomon, see, on that west side. See, that's open water there. And up. So this is Russia here. Now this is the ESAS right along here, where we were seeing that methane come up on CAMS. So let's see what else we can see. There is definitely an art to looking at this nighttime layer. So here's open water. This is by Alaska. That's the western edge of Alaska. Because you have to look through clouds too. And if the clouds are thin, you can see through them and see the leads in the ice and the cracks and the chunks and things like that. But if they're too thick, you just can't. So there's that. Let's go back to today. Let's see. Oh yeah, this is very visible today. This is by Franz Josef Land. See, Look at this. See, open water there. See, this is all of this is Severnaya Zemlya. Here's a hole by Komsolomets. Now watch. See, it's all along that coastline, and it leads right up to the Russia coastline there. See, right there. Here's Novaya Zemlya. Let's look at this. Kind of cloudy to see that. So let's just look at it naturally now. So we've got a lot of clouds, but we can see the ice edge here on the west side. See, it's all in the sun. Here's Svalbard. See? See this foot, this right foot, it's in the sunlight now. Longyearbyen is in the sunlight. It's right down here. That's where the seed vault is. Look. Open water. Here's the Yamal Peninsula. Now you can, they've run icebreakers through here. You can see the channel. That's why I'm thinking that area on the northwest side of Greenland is from icebreakers. It looks similar. Now, see, look at all that open area. Here we are. This is ice. See the... Now this is the edge that kind of is a little thicker around the coast, and then this is where it refreezes up to it. Now we've got a bunch of clouds here. Okay, here we see the leads in the ice. See that? Here's some more. You can see those. So when you can see them, they're really prominent. So there's that. Now I want to go over some earthquakes. Oh, I've got one more thing before we look at earthquakes. I've been watching this sulfur dioxide. Now this is from the 22nd, and I've been saving these pictures. I stopped saving them for a while, but now going back every day and saving at least the global sulfur dioxide pictures from CAMS. But watch over here. This is from Mount Etna blowing up. Here's the 22nd. Here's the 23rd. 24th. Look at that. 25th. 26th. 27th. And today. So it's really putting a lot of sulfur dioxide up into the atmosphere, and it's still erupting. So I thought that was interesting. Now I'll go over earthquakes. I took these pictures this morning. There were 180 worldwide. Now that's a low number considering everything that's been going on. We've had a lot of earthquakes up here at Iceland this week. There's another one right there. But you can see all the movement. We've got plate movement going on. So we'll just click through these. Here in the lower 48, we had 105 today. Here in Southern California, there were 31. Ridgecrest, Searles Valley area, there were 11. Now that blue one up at the top was a 3.6 at Lone Pine, California. That was the largest one. From western Nevada, from Tonopah over to Mammoth Lakes, we had 20, with the largest one being a 3.1 at Bodie, California. This is in southern Nevada, a 3.4 at Rachel, Nevada. So we're seeing some larger earthquakes today. This is along the San Andreas fault line from San Jose down. We had 7 here, with the largest one being this 3.7 at Lopez Point, California. It was just off the coast there. The geysers had 20 today. The largest one was a 2.7. Here in the Pacific Northwest over to Yellowstone, nothing in the Pacific Northwest. And they're all at Stanley, Idaho. There were 6 here today. So it's definite downtick. Here we have a 2.6 at Crawford, Nebraska. We can see that's in the northwest corner of Nebraska, just next to South Dakota and Wyoming. Here's a 2.8 at Stanton, Texas, northeast of Midland. Oklahoma is showing 5 today. The largest one was a 2.8 at Tatum's. We've got 2 in the New Madrid area, a 1.6 at Ridgely, Tennessee, and a 1.7 at Tiptonville, Tennessee. Puerto Rico's only showing 5 today, so that's a downtick. This is on the Cocos Plate in the Pacific, just off the coast of Costa Rica and Panama. We had a 4.8 and a 4.6. South America is showing 3. The largest one was that 5.5 near Islay, off the coast of Peru. Hawaii is showing 11, and that's a low number for what they've been having. Alaska is showing 43. The largest one was this 5.4 near Adak here in the Aleutian Islands. Now there's a big dot here by Anchorage, so here's a close-up of that. There was a 5.3 near Port Mackenzie, which was just across the bay from Anchorage. Here in the South Pacific, we're only seeing 2, a 5.3 and a 4.9. And only one in near Bengkulu, Indonesia, 4.6. So this is a way lower number than what we've been seeing. These 2 are just south of Japan, a 4.7 and a 4.8. And then here's a 4.5 in the Kuril Islands region, just north of Japan. This is near Nepal, a 4.1. This is on the Tibetan Plateau. Here's a 4.1 at Hoshtrud, Iran. just west of the Caspian Sea. And we have two in this picture, 4.1 at Lopatari, Romania, and then a 4.5 off the coast of Greece. And then we have one south of Africa, 5.0, right on the red line there. And then last but not least, we're still seeing movement at Iceland of 4.6 at Álftanes, Iceland. There's that. Now let's look at the site. I want to turn on, look, see, we've got movement still, 5.9 Port Vila, Vanuatu. So we've got some new dots here. I want to turn on all magnitudes, 7 days, all magnitudes. I want to show Iceland. We've got 14 here. Look at this. And this is, the lowest one was, what, a 3.9 here. The largest one was a 5.6. This all started on the 24th. It started with a 4.5, and then the 5.6, and then they've just been coming in ever since then. Then that's in the 5.2. Oh, sorry, yesterday. But all in this area near Reykjavik. But if you look on EMSC, there were a lot more because they get the little ones too. One day I looked and there were 23 in one day on EMSC and only 7 on USGS. So there's something definitely going on there. You can see this is the tectonic plate line running right through there. And next to Greenland. So this is to be expected, and we'll see more and more and more of this as time goes on. So I'd like to finish up. I'm reading the book of Luke now, and this is the life of Jesus. The words in red are Jesus' words. Luke chapter 16. And he said also unto his disciples, There was a certain rich man which had a steward, and the same was accused unto him that he had wasted his goods. And he called him and said unto him, How is it that I hear this of thee? Give an account of thy stewardship, for thou mayest be no longer steward. Then the steward said within himself, What shall I do? For my Lord taketh away from me the stewardship. I cannot dig. To beg I am ashamed. I am resolved what to do, that when I am put out of the stewardship, they may receive me into their houses. So he called every one of his Lord's debtors unto him, and said unto the first, How much owest thou unto my Lord? And he said, 100 measures of oil. And he said unto them, Take thy bill, and sit down quickly, and write 50. Then said he to another, And how much owest thou? And he said, 100 measures of wheat. And he said unto him, Take thy bill, and write 80. And the Lord commended the unjust steward, because he had done wisely. For the children of this world are in their generation wiser than the children of light. And I say unto you, make to yourselves friends of mammon, of unrighteousness, that when ye fail, they may receive you into everlasting habitations. He that is faithful in that which is least is faithful also in much, and he that is unjust in the least is unjust also in much. If therefore ye have not been faithful in the unrighteous mammon, who will commit to your trust the true riches? And if ye have not been faithful in that which is another man's, who shall give you that which is your own? No servant can serve two masters, for either he will hate the one and love the other, or else he will hold to the one and despise the other. You cannot serve God and mammon. And the Pharisees also, who were covetous, heard all these things, and they derided him. And he said unto them, Ye are they which justify yourselves before men, but God knoweth your hearts. For that which is highly esteemed among men is abomination in the sight of God. The law and the prophets were until John. Since that time the kingdom of God is preached, and every man presseth into it. And it is easier for heaven and earth to pass than one tittle of the law to fail. Whosoever putteth away his wife and marrieth another committeth adultery, and whosoever marrieth her that is put away from her husband committeth adultery. There was a certain rich man which was clothed in purple and fine linen, and fared sumptuously every day. And there was a certain beggar named Lazarus, which was laid at his gate full of sores, and desiring to be fed with the crumbs which fell from the rich man's table. Moreover, the dogs came and licked his sores. And it came to pass that the beggar died, and was carried by the angels into Abraham's bosom. The rich man also died and was buried, and in hell he lift up his eyes, being in torments, and seeth Abraham afar off, and Lazarus in his bosom. He crieth and said, Father Abraham, have mercy on me, and send Lazarus, that he may dip the tip of his finger in water, and cool my tongue, for I am tormented in this flame. But Abraham said, Son, remember that thou in thy lifetime receivest thy good things, and likewise Lazarus evil things. And now he is comforted, and thou art tormented. And beside all this, between us and you, there is a great gulf fixed, so that they which would pass from hence to you cannot, neither can they pass to us that would come from thence. Then he said, I pray thee therefore, Father, that thou wouldest send him to my father's house, for I have 5 brethren, that he may testify unto them, lest they also come into this place of torment. Abraham saith unto him, They have Moses and the prophets, let them hear them. And he said, Nay, Father Abraham, but if one went unto them from the dead, they will repent. And he said unto him, If they hear not Moses and the prophets, neither will they be persuaded, though one rose from the dead. Luke chapter 16. So I'll be praying for everybody. and time is short. We can see the evidence of it. This is why I do this work, to show you from week to week and day to day how dire the situation is, and we can see the signs all around us. And I recommend you get your spiritual house in order, and if you haven't done so, giving your life to Jesus Christ, then do that before it's too late. Because Jesus said, I am the way, the truth, and the life, and the only way to my Father's kingdom is through me. And I believe that, and I do follow Him. He is my Lord and Savior, and that is my testimony. So until next time, I'll be praying for you. I hope you have a good week, and God bless you. Go in peace, and I will talk to you soon. I love you all. Goodbye.